in addition to simplifying fractions, we can also multiply and divide fractions. And so that's going to tell us how to multiply and divide rational expressions as well. If we have 2/9 multiplied by 15/28, then the way we can do this, one option is, remember to multiply fractions, you just multiply across. Numerator by numerator, denominator by denominator. 2 times 15 is 30. And 9 times 28 is going to be 252. And then we don't want to leave it like this because we want it in, again, lowest terms. So we need to simplify it. Well, what's in common? Well, if you search through the factors, you'll see that there is a 6 in common. Okay. And so dividing out that 6, we get 5/42. And that's fine. So what we do is we multiply numerator by numerator, and we multiply denominator by denominator, but then we also need to write it in lowest terms. Well, we have another option. We can still do both of those things, but reverse the order. So first, let's identify common factors. Then, after we divide those out, we'll multiply. We'll end up working with smaller numbers. See, we can notice that even though there's no common factor between 2 and 9, there is a common factor between 2 and 28. Okay? It's a 2. 2 is 2 times 1. 28 is 2 times 14. So we'll be able to divide out that common factor because 1's in the numerator and 1's in the denominator. It doesn't matter that these are separate fractions because when we multiply them, they're going to get put together anyway. Now, similarly, the 9 and the 15, there's a 3 in common. 9 is 3 times 3. 15 is 3 times 5. And so when we divide out these common factors of 2 and 3, then what we end up with is 1/3 times 5/14, and then multiplying. 1 times 5 is 5. 3 times 14 is 42. You see, we end up with the same result, but we were working with smaller numbers along the way. We didn't get these giant numbers up here. And notice that we did the same thing. We divided out the common factors 2 and 3. Here we divided out the common factor of 6, which is 2 times 3. So this second option is going to be a lot more useful for us when dealing with rational expressions, because if we don't divide out the common factors first, we're going to end up with very large polynomials in our numerator and denominator, and then we're just going to have to factor them anyway to see if there are common factors so we can write it in lowest terms. So we're going to save ourselves some work by first doing the factoring so that we can divide out common factors. Then we will multiply. So let's see an example. Here are 2 examples. First one, x squared plus 6x over 5x plus 30 times 10 over x squared. What are we going to do to multiply these? First, we need to factor every numerator and denominator so that we can divide out common factors. All right, so we factor this numerator. X squared plus 6x factors as x times x plus 6. If you are not good at factoring, you are going to want to brush up on that. You will be doing factoring extensively when working with rational expressions. 5x plus 30, to factor that, there's a 5 in common. Okay. Ten, well, there's nothing to factor there. Monomials can't be broken down into smaller polynomials. Although I can factor this numerically as 2 times 5. X squared, nothing I can do, it's just x times x. So what do I have? Well, here's what I have in common. I have an x plus 6 in common, clearly. I can divide that out. I have an x and an x, so I can divide that out. Only one of the x's down here. And I have a 5 and a 5. I can divide those out. Leaving me with, this is just 1. 1 times 2 is 2. This is just 1. All I have left here is x. 1 times x is x. So when I multiply these together, I get 2 over x in lowest terms. Now this one, we'll do the same thing. We've got x cubed minus y cubed over x squared minus y squared times x plus y over x minus y. Factor the first numerator. It's a difference of cubes. So it's going to be x minus y times x squared plus xy plus y squared. The denominator is a difference of squares. So it's going to be x minus y times x plus y. X plus y is just linear, a linear binomial, so there's nothing more we can do with it. It's not a difference of squares, a difference of cubes, or a sum of cubes. Same thing is true of x minus y. So what do we have? Well, we have an x minus y and an x minus y that we can cancel. But I also have an x minus y over here. What do I do with that? Well, I have to pick one or the other of these. It doesn't really matter which one, and divide it out along with this one on the top. Okay. One of them is going to be left. Similarly, x plus y I have in common. And so the end result is x squared plus xy plus y squared over x minus y. Now what about dividing? Well, remember how to divide fractions. It's one more step beyond multiplying fractions. To divide by a fraction, we can multiply by its reciprocal. So keep the first fraction the same, flip the second fraction, and change the sign to multiplication. Now we can divide out common factors, a 2 there and a 3 there, and we end up with 3/4. Well, it's the same with dividing rational expressions. Okay, we already know how to multiply them. So to divide rational expressions, we can do the same thing. Let's say we have 12x to the 4th over 5y cubed divided by 3x to the 5th over 25y. Well, again, this is going to be the same as if I keep my first one the same, flip my second one, and change my operation to multiplication. So I'm dividing by the rational expression by multiplying by its reciprocal. And again, canceling common factors. There's a 3 in common here, a 5 in common here, x to the 4th and x to the 5th, so 4 x's in common, and y cubed and y, so 1 y is in common, leaving 2 down here. And so we end up with 4, let me write it out, 4 over y squared times 5 over x. Multiplying across, we get 20 over x y squared. Let's see one where we have to factor x squared minus 25 over x plus 4 divided by x minus 5 over 2x squared plus 7x minus 4. Well, again, we're dividing, so we can start out by multiplying by the reciprocal. Now, factor these to see what common factors there are. X squared minus 25 is a difference of squares. So this is x plus 5 times x minus 5. X plus 4 is prime. 2x squared plus 7x minus 4 is going to factor as 2x minus 1 times x plus 4. And x minus 5 is prime. So what's in common? Well, there's x minus 5 up here and down here. We can divide those out. There's an x plus 4 down here and up here. We can divide those out. And so in the end, we get on top x plus 5 times 2x minus 1. And on the bottom, just a 1. Well, we don't need to write that. It's just the numerator then. And if we want, we can multiply those out. 2x squared minus x plus 10x is going to be plus 9x minus 5.